Okay, class, so welcome to our last lesson here with sequences in series. So a sequence you've seen before. Sequence is simply a list of numbers. So for example, we can have 1, 3, 5, 8. That is a sequence of numbers. Now we can have a finite sequence where we go dot, 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 and then we list our last term, which I'm not sure, maybe we say it's 120. Now I haven't worked out the sequence altogether. What happens is each term follows a pattern and then goes all the way up to your last sequence. So that is a finite sequence. The finite means there is an end. Okay, so if with finite there's an end, and if there's infinite or infinite, okay, then it continues forever. So infinite and finite. So finite has an end where infinite goes forever. And we show you that by here is an end number. Okay, so that is an ending number, and this means goes forever. So what you'll notice with me is I kind of combine that in the sense that there is some missing numbers here. This here indicates missing terms that follow the pattern. Okay, so missing terms that follow the pattern. And so we have to introduce then the letter n. So n is the number, term of the sequence. So n equals the number of the term. Okay, the term number. So for example, looking at my sequence, or this sequence here, this would be n equals 1, n equals 2, n equals 3, n equals 4. Okay, n equals 1, n equals 2, n equals 3, and this last one, n equaled 4, because it is the fourth term in the sequence. So that's what n equals. Okay, and so what we can do then is we can find the domain. So the domain, which is a set of positive integers. So instead of saying A1, that is the first term. Okay, so the first term in the sequence. And AN, that would be the formula used to find the terms. Okay. So here we have A subscript 3, that's the third term. A subscript n is the nth term of the sequence. And the entire sequence is usually denoted by AN. Okay, so an example here of a finite sequence, you have a number there, and here you have no number for infinite. So let's have a look at a couple different examples of the sequence. Here we have a sequence, AN equals n plus 1 over n. So for the first term, the n becomes 1. So A subscript 1, n equals 1. And so you'd substitute in. And so you can see that I replace the letter n with the value of n. And so when you do that, you get 2 as your answer. Then for subscript 2, I replace n with the number 2. And so we get 3 over 2, and that is the answer for the second term. For the third term, n equals 3, and so now n is replaced with the number 3. We do our BEDMAS, and we find the third term is 4 over 3. Then for the fourth term in our sequence, n equals 4, so replace n with the number 4, and then we get 5 over 4, and that's the fourth term of the sequence. So you can see that example then also goes for sequence B and also for sequence C. Okay, and so all you're doing is you would substitute n into substitute the n value into the sequence to find the term. And of course, you would simplify the sequence using BEDMAS. Okay, good. So then you could see here, it's pretty straightforward. You substitute in for the first term the number 1 for n. 2 times 1 minus 3 is -1. For the second term, you substitute in the 2, and then you do BEDMAS. It simplifies then into a 1. For the third term, you substitute in a 3, and then you do BEDMAS, and you get a 3. Fourth term, you substitute in a 4. Okay, so just substitute in, find the values of the terms. Another way of defining sequence is to find the first term or the first few terms, and then specify the nth term by a formula involving the preceding terms. Okay, so if you're doing that, then it's called recursive. So you write the first 4 terms of the recursive formula. So we're using this formula, and so you could then substitute in, okay, for a equals 1, you substitute that in, and you get 3. A equals 2, you substitute in, and you get 3 over 2, etc., etc. What's changing is that this changes each time. So here A1 equals 3. That's the very first value that's given to you. Okay, and then for A2, you're going to substitute in A1 value, because we have our subscript 2 minus 1, and so we get 3 over 2 because A1 is the number 3. For A3, again, you do your subtraction here, you get A2, and you know that value, you found it right here. So that gets substituted in up top, and what you're going to get is A2, which is 3 over 2, divided by 3. And that equals 1/2. So really what that is 3 over 2 divided by 3, which is 3 over 2 times 1/3, which equals 3 over 6, which equals 1/2. So you can get pretty complicated with your math. Don't write it in this format. You want to then change it so that it's this format, so you know that you don't divide. You multiply by the reciprocal because you're dealing with fractions. Good. Next, moving on, sigma notation. So sigma notation right here, it's just rewriting this into a simple, compact way. So what? Good. Okay, so going on about sigma notation, what you're doing is just finding the sum of all the terms. Okay, so let's just see here. Sigma notation, often it's important to find the sum of the sequence. So the expand notation is here. To do that in a short form, what you use is your sigma notation. So there you go. Something new, you've never seen that before. It's like a capital letter E almost. Okay, so what we have at the bottom is we have k equals 1. So that is the start value of k. Start value, and at the very top we'll have the end value. So we'll go over one of these and then it's going to make sense, even though it looks really Greek. Haha, it is Greek. So we have this sum of AK has n minus k plus 1 terms. Don't worry about all the jargon. Let's focus on doing this example. So this example, now we have k equals 1. So term 1 is, okay, term 1 is 2 times 1 plus 1. So 2 times 1, well, that would equal then 3. So term 1 is 3. Term 2 then is 2 times 2 plus 1. So 4 plus 1, which is 5. Okay, so continuing then, the third term. So Now k equals 3, and so we're going to get 2 times 3 plus 1, so 6 plus 1 is 7. And then for the fourth term, we're going to get 2 times k equals 4 plus 1. So I'm substituting the k value into the formula, and I get 8 plus 1, 9. So you can see 1, 2, 3, 4. And then what we have, add them all together. So we're going to get 3 plus 5 plus 7 plus 9. So you find the terms first, then you add them together, and you get 24. So that was find the sums of the sequence. Okay, so the 24 is the sum of the sequence using the sigma notation to identify. So here is your formula. This is your start term or your start value, and this is your end value at the top. Okay, and so then you can do that for B and C, and you can see your solution below. All right. So next here, example number 4, write the sum using the sigma notation. So you have to identify what's going on and work from there. Okay, so first of all, you got to look and see what's changing by 1 each time. So here you're increasing by 1, and this is increasing by 1 as well. So at the top, this will be the first term, second term, third term. So you can see that n is just on the top values. So on the top we have n, on the bottom we are getting n plus 1. Okay, and so that works for this one as well. And the last one really helps you. Now you can see this will be the 12th term, right? N equals 12. And then here we have n minus 1, so 12 minus 1. And so that's why they changed n to the letter k, but you're using the letter k. K is 1 and going to 12. Okay, these take a little bit of harder guessing and checking and practice. Away you go. Okay, so arithmetic sequence. Away you go. And then finding the nth term of an arithmetic sequence, you're going to use this formula for any integer. Boom, go, have a look. Most of you are only going to do example number 1. I just wanted to show you the different terminology and what it means. Okay, any questions, let me know.